In this video on algebraic expressions, we're going to have a look at algebraic fractions with multiplication and division. When working with algebraic fractions, all the basic principles of normal fractions are still valid. When you want to simplify an expression that consists of a fraction, we want to divide the numerator as well as denominator by the highest common factor. And in this case, that is 4. So when you rewrite this in terms of factors, we will have 4 times 3 divided by 4 times 7. And here it is clear to see that when you divide the numerator as well as denominator by 4, you will end with the simplified fraction. This same principle is true when working with algebraic fractions, and that is why we will always break the numerator as well as denominator up into factors so that we can divide by the common factor. Let's have a look at an example. Example 1. Simplify. Here we are given one term that consists of a fraction, and as I've just mentioned, we will then start by breaking the numerator as well as denominator up into factors. This means we will have to factorize. The numerator consists of 2 terms, and they have a common factor of 3p. That means we will be left with p minus 2. The denominator is already one term with the factors 6 times p. And now we can divide by the common factors in the numerator and denominator. Therefore, we can say p divided by p is 1, and 3 divided by 6 is a half. Therefore, our final answer has 1 times p minus 2 in the numerator, or simply p minus 2, over 2 in our denominator. A common mistake to make in a fraction like this is to simplify too early. Here, learners sometimes tend to say 6p divided by 6p is 1, and the answer is simply 3p squared minus 1. This is completely wrong. If you think about a basic example, and we use this specific simplification method, you will end up with 5 minus 1, which is 4. But in reality, when this is simplified correctly, we know the answer is 2 over 3. Therefore, it is very important to remember that you can only simplify by dividing the numerator and denominator by the highest common factor when there is only one term in the numerator as well as denominator. Example 2. Simplify. Here we once again have one term which is a fraction, but both the numerator as well as denominator have more than one term. Therefore, we need to determine the factors of both by factorizing. In the numerator, we have difference between squares, and that will be x minus 3 and x plus 3, and in the denominator, we have a trinomial. After we factorized, we now have one term in the numerator as well as denominator broken up into factors, so we can simplify by dividing by the common factor. So I can now divide top and bottom by x minus 3, and I'll be left with x plus 3 at the top and 2x plus 1 in the denominator. This is now our final answer. Be careful not to now also simplify by dividing away the x's, and the reason for that is there is more than one term in both the numerator and denominator, so we are not allowed to simplify. In example 3, we are still asked to simplify and we still have one term. But this term now consists of 2 fractions. Therefore, we now need to break each numerator as well as denominator up into its factors. The first numerator cannot be factorized any further. Therefore, I simply put it in a bracket and take out a common factor of 1. The denominator here is a trinomial. Next, I'm reminding you that you can change a division sign into multiplication by writing the reciprocal of the fraction after that. Therefore, The numerator will now be x squared plus 5x, and the denominator will be x squared minus 4. Next, I can now also factorize this second fraction, and in the numerator I will take out a common factor of x, and the denominator is difference between squares. Here we now have one term with 3 factors in the numerator and 4 factors in the denominator. Therefore, we can simplify by dividing by the common factors. I can divide top and bottom by x minus 2 as well as x plus 5. And in my numerator, I'm now only left with x, and in the denominator we have x minus 1 multiplied by x plus 2.